In this discussion video, we will do some U-substitution examples. So I first want to look at problem number 8 from worksheet 14, which wants us to calculate the integral of square root of 1 plus x dx. Part A says to do this using the U-substitution u equals 1 plus x, and B says using u equals the square root of 1 plus x. Okay, so I want to give you 5 minutes to try this question first. Pause the video in 4, 3, 2, 1. Pause it for 5 minutes to try A and B. All right, so hopefully you did that. Hopefully you paused it and tried them for about 5 minutes. Let's talk about it now. So for A, it tells us what u sub to try. Let u be 1 plus x. Okay, so then what I do is I take the derivative, du dx, and on the right-hand side, that derivative is 1. And recall what I do then is I treat the du dx as a fraction, even though it's technically not a fraction, and I move the dx over the right-hand side. So we'll get du equals dx. So this step we are treating the du dx as a fraction. And in our lecture videos, we gave a more rigorous explanation as to why these are equivalent in the du dx form and in this other form where the dx is moved over. Okay, so using this, what we now get with our integral is we get the integral, and I plug in for a u, and I get square root of u, and we know dx is du, so we get du. So this is square root of, it's the integral. Let's rewrite root u as u to the 1/2 du. Now it's just a reverse power rule. So I get u to the 3/2 divided by the new power, 3/2. Maybe you already multiplied by the reciprocal. This is plus c. And now I got to plug in for u. And now when I divide by the fraction, that's the same as multiplying by the reciprocal, which is 2/3. Plugging in for u, we'll get 1 plus x to the 3/2, and then plus that c. And that's our answer. Okay, so that is the antiderivative of this function that we had. Part B says, well, let's try this another way. Let's try this with a different u sub. Let's try letting u be square root of 1 plus x. So I need to take this derivative, and for the derivative of this, let's rewrite this as 1 plus x to the 1/2 power, because now I do chain rule. So this time when I do the derivative, instead of writing du dx, and then saying what that equals, and then moving the dx over on the next step, I'm just going to go straight to writing du here, and then when I take the derivative, I will write a dx on the right. So if I do chain rule, this derivative will be 1/2 times 1 plus x to the negative 1/2. And then I multiply by the derivative of the inside, the 1 plus x, which is 1. Okay, and then I can't forget to write my dx, which I have now moved over. Okay, so if we simplify this, we get du equals, this is 1/2, square root of 1 plus x on the bottom, when I move this negative 1/2 power to the bottom, dx. And let's handle this by isolating the dx. So we'll multiply the 2 and the root 1 plus x to the left. We get times du equals dx. And now let's go ahead and plug into our integral. So now our integral becomes the integral. So now the whole square root is just u. So we'll just get u and plug in for dx. Well, dx is 2 times root 1 plus x du. So one thing that's annoying is I did this u sub, but I still have x's in my integral. One strategy for what we can do there is we just try using our u sub again. U was square root of 1 plus x. Let's just use that again. And this one I would say is extra nice because I see that exact thing in my integral. So if we plug in, we get, let me pull the 2 out to the front because it's a constant, times u times this square root thing. But the square root thing is just u. And then we have that other du. Okay, so we have 2 times the integral of u squared du, and that one's not bad at all. Let me write that squared better. Squared, let me still write it better. Squared du. So now doing this antiderivative, we'll get 2 times u to the 3rd over 3 plus c. Then I got to plug back in for what u is. So we get 2, let me write this as 2/3. 2/3. And what was u? U was the square root square root of 1 plus x. And then I got that plus c out there. And I could rewrite this so it matches the answer that I had before. This becomes 2/3. And this square root being raised to the third power, well, that's just 1 plus x to the 3/2 power plus c. And that's our answer. So notice in this problem that there were 2 u-subs that worked, that led me to a correct answer. So before I do another example, I want to talk about a key takeaway from this, which is that many u-subs that we might apply can transform our integral purely in terms of u, but I want to make 2 remarks. I'll put an arrow here. The first remark is sometimes one choice for u is best. And for this question, I would say the first choice of u was definitely a little bit quicker. All right, and the other remark is that not all u-subs, I'm going to underline not, so not all u-subs will actually help. And this problem, it was a little bit unique in that both of these u-subs actually helped and I could actually do my integral. But sometimes in a problem I may try a u-sub and it really won't help. Maybe it'll make my integral harder to do. Okay, so let's do another practice problem. So let's look at problem number 10 from this worksheet. And I want to look at just part A and have you try A first for 3 minutes. So pause the video for 4, 3, 2, 1. Pause the video, pause it for 3 minutes to try this question. Just part A. All right, so hopefully you did that. Hopefully you paused it and tried it for about 3 minutes. So most questions, especially when we start to talk about, do I use u-sub or not use u-sub, will be like this, because I won't just tell you what the u is. Usually if you're given what u is, it makes it a whole lot easier. Part of what can make u-sub questions more challenging is you have to figure out what to let u be equal to. Okay, so for this question, hopefully you've tried some things. Maybe you already discovered what the right choice for u is, but we want to let u be the denominator, x to the third plus 1. Because then when I take the derivative and I write du, that's going to be 3x squared. Don't want to forget the dx, because I've moved the dx that used to be on the bottom over. That's really important. So if I isolate the dx, we'll get du over 3x squared equals dx. Okay, so one tip for why this is a good choice of u, or how to recognize what a good choice of u is, and we mentioned this in our lecture videos, is when we look at this du, we want du to appear in our integral, but maybe up to a constant multiple. So my du had this 3x squared dx, and I see that in the integral because I see x squared dx. It's just off by a constant multiple. It's off by this factor of 3, which is going to be just fine, and we'll see that when we plug in. All right, so now when we substitute in, on the numerator I have x squared. On the bottom, well, that was u, and my dx is du over 3x squared. And now this is nice because of this constant multiple thing, and it was just off by a constant multiple. And now I get this perfect cancellation of the x squareds. And I can pull this 3 on the bottom out to the front. So I get 1/3 integral of 1 over u du. And I know that antiderivative. So this is 1/3. I will get ln absolute value of u plus c. And then finally I got to plug back in for u. And I get 1/3 ln absolute value of x to the third plus 1 plus c, and that is our answer.